Okay, so the next term you need to know is a congruence transformation. We've already talked about rigid motions, and then each individual transformation, such as a translation, a rotation, or a reflection, are all rigid motions, which means those transformations are also congruence transformations. You could have a single transformation, the ones that I just mentioned, be a congruence transformation. You could also have a composition of transformations, be a congruence transformation as well. For example, you should have seen that the glide reflections, so a translation followed by a reflection, are also congruence transformations. So congruence transformations are just a transformation that produces a rigid motion. And we'll take a look at some examples of congruence transformations. Okay, so on example or problem number 3, it says describe a congruence transformation that maps polygon ABCD to polygon EFGH. So in order to map polygon ABCD to EFGH, again, take a look at each of the individual vertices or letters. A has to correspond with E and so on. But I don't think there's just a single transformation that you could use for the congruence transformation. And there's actually a bunch of different ways that you could describe a congruence transformation. So the way I'm about to go through it might not be the way that you're thinking, and then you could also be correct. But one congruence transformation is first a reflection. So you could reflect polygon ABCD over the line x is equal to 2. So if you reflect the polygon ABCD over the line x is equal to 2, you end up with what I have there in blue. I didn't label everything. Basically, I could label this C prime, B prime, A prime, and then D prime. But then, in order to come up with polygon EFGH after the reflection, since there's not just one congruence transformation, I could use a composition. Then I could use a slide, or specifically a translation. So again, A prime, B prime, C prime, and then D prime. If you just want to look at one of the points, A translates down 5 units, so does B, and so on. But a translation, 5 units down. I could also use vector notation. I could use ordered pair notation as well. I could just say translation 5 units down, and then that would be a congruence transformation. Again, you can get a lot fancier. You could say reflect over, I don't know, the y-axis or x equals 0, and then the translation would be to the right and down a certain number of units. And you could do something like that, get a little bit more complicated, but there's a different number of congruence transformations besides the one that I just went over.